Question number 38. A pure sample of 4.4 grams of radon-222 has an activity of so much. What is the decay constant of radon? Now, how do you get the decay constant from this activity? You know that lambda times n is equal to E. Okay, if you know the value of n, then you can get it. See, in thermal physics, you have come to know about how mass and the mass number can be equated, and then you can get the value of the number of atoms. I'll do it once again if you want. See, whenever you have this radon-222, some number over here along with the element, what is that you get? You can say Avogadro number of atoms will weigh 222 grams per unit mole, right? And if that is the case, now how many number of atoms will weigh 4 grams, 4.4 grams, 4.4 grams, the same element? That's what is the question. So now get the value of x. X will now be equal to 4.4 divided by 222 multiplied by Avogadro number. Unitary method I have used. Okay, so I just divide x by Na equal to 4.4 divided by, I did like this, x by Na divided one by another. Okay, is equal to so much, or x is equal to this much plus so much. Okay. This by x is equal to 4.4 divided by 222 into n. So now these number of atoms are present over. So I have got, what is this now? This is nothing but your capital N. What's the next step? To plug in this value here. So lambda multiplied by 4.4 divided by 222 multiplied by 6.023 multiplied by 10 power 23 is equal to 2.5 into 10 to the power of 16. Right? So lambda will now be equal to 2.5 to 10 power 16 to 222 divided by 4.4 into 6.02 to 10 to the power 20. Let us do the calculation to get to know what is the final answer. So I have 0.5 equal to excuse me, divided by 4.4 is equal to so much divided by 6.02, give me 20.95. 10 to the power of, here you have 16, you have 23. 16 minus 23, which should be 20.95 into 10 to the power of 16 minus 23 is minus 7, and this should be 2.95, 2.095, I'll make this 2.1 into 10 to the power of minus 6. This should be your answer. 2.1 into 10 power minus 6, and then C.